Hello, welcome to another coding challenge. This one is a follow-up on the previous fractal tree coding challenge. One of the first things that people often ask me when they first see a fractal tree is, oh, I want it to grow from the bottom. So how do you have it grow from the bottom? This is also the same question as, oh, I want to put leaves on it and then have the leaves fall. So while the fractal demonstration I did in the previous video is a good demonstration and a useful technique, you might need a different way of creating the tree to be able to do more types of animation-like things with it. And the way of doing that is to, rather than draw the tree all at once in a recursive function, is to actually build the tree out of objects. So what I need in the tree, it's over here, I'll just use this as my reference, is I want to create an object that's a branch object. And the branch object only needs two things. It needs a start point and an end point and a display function that just draws itself there. So let's look, and I'm going to build from the previous code, and I'm going to just from scratch take the previous code which draws this fractal tree and change it into something that uses an object, branch objects, and an array. Okay, so let me go back to the code. And here we are. And one of the first things I'm going to do actually is just create a new JavaScript file. I'm using the Atom editor with the P5.js JavaScript framework. But there's lots of different ways you could program this. And I'm going to say new file. And I'm going to call this new file branch.js. And then I'm going to go into index.html and make sure I include a reference to branch.js. So now I have two JavaScript files I can work with. And what I'm going to do in branch.js is I'm going to write a constructor function called branch. And what branch needs is, when you create a branch, it needs a start and an end. There's actually different ways of doing this, which you'll see later. And I'm just going to call, and I'm going to say this.start equals start, and this.end equals end. So the first thing I need to do now, start. So one of the things that often happens, which one of these is colored weirdly? Start is. So it looks like start is maybe a key word in JavaScript for something else. It shouldn't really matter here, but I'm just going to call this then beginning. Begin and end, just to kind of get away from that. Okay, so that's the branch, a branch object. And I know I could use if some of you were like watching this being like, oh, maybe you should use a JavaScript object literal, and I could do that too, but I'm kind of using this constructor function because I'm going to add more to it, and you'll see hopefully later why that's kind of another way of doing it that could be useful. So I'm going to go back to the code, and right here, when I first call this branch function, what happened in the first program is I translate to the bottom, call the branch function, which draws a line. But instead, what I want to do is say, I'm going to make a variable called root, which is the root of the tree. And I'm going to say it's a new branch, which goes from where? The center of the screen, width divided by 2, to where? Like width divided by 2, height. Oh, so so I'm doing stuff and just programming, and I got lost in my thoughts for a second. You know what I really need is, interestingly enough, let's go back and look at this. I said, oh, there's just two things involved in this branch, a beginning and an end. But what are those things? The beginning and the end, those things are points with an x and a y. And one way that I can store a point in P5.js is using a vector object, a P5 vector object, which is an object that has its own x and a y. So what I'm actually going to do is I'm going to say, I'm going to be very long-winded about this just to be quite explicit. I'm going to say a equals create vector, and I'm going to make a vector that's at the bottom of the window, width divided by 2, comma height. And then I'm going to say b is a vector that is also in the middle, but not at the bottom. It's at the bottom minus this length, or 100, minus 100. And then I'm going to make a branch which goes from A to B. And then what I want to do, and I actually don't need this whole recursive function anymore. And this should be in setup, by the way. And I'm going to get rid of this slider. We can come back to using that slider later. I guess I'm starting from scratch. And in draw, I'm going to say root.show. What I want to do is take that, and this needs to be a global variable. So what I'm trying to demonstrate right now is I can make a single branch object, which is just the root of the tree, and I can display that root. And so I need a function called show. And so I'm going to add a function called show. And all that show does is stroke 255, draw a line from this dot beginning dot x, this dot beginning dot y, to this dot end dot x, this dot end dot y. So you're going to see here that a branch is just an object that has a beginning and an end point, and it's displayed as a line between those 2 points. So now if I come back to here and run this again, you can see there's our first branch. So we kind of double back. We're doing the same thing we did before, but in a different way. Okay, so let's think about now. Now here's the thing. What I need is for every branch to spawn 2 branch objects attached to it. How are we going to do that? So one thing I need actually is I'm going to have more than one branch, so I need an array. So I can, what the tree essentially is, I don't need this root anymore. I'm going to make a variable called tree, and tree is just an array. So it's an empty array, and then this root is the first thing that goes in the tree. And then, and I know that camera just went off while I'm in the middle of my typing. I'm going to put it back on. In the middle, what I'm going to do is then draw all of the trees. So now my structure is I have an empty array. I create the root of the tree. I put the root in the array, and then I display the array. And once again, I'm missing a curly bracket. Once again, I still have that one root. Now comes the time where I can attach to that root 2 more branches. So how can I do that? Well, one way that I could do that would be to add a function. This branch object, what if this branch object had a function within itself that knew where its end is and knew how to spawn 2 more branches from that end? So let's look at that. So I'm going to go back to this branch object, and I'm going to write a function called, and I'm actually just going to call it branch. I don't know if I have a naming conflict anywhere, but I'm going to write a function called branch. And what that function is going to do is it is going to create 2 additional branch objects attached to this branch object. So how do I do that? So I'm going to call the right branch is a new branch. I hear voices. Somebody might be coming. Who knows? There's something there. I don't know. I started thinking about West Side Story, one of my favorite musicals. There's definitely people here, and I lost my train of thought. Okay, I need to make a branch. So where does let's think about it. I need a diagram. I'm going to come over here. Okay, so if I erase this diagram, how am I doing this? I have this branch. This is begin. This is end. Now I need a new branch. So this new branch, its begin point is the previous end point. And then I need to calculate where is its new endpoint. And the way that I might do that is by rotating this line. So I'm going to need to use some trigonometry and math for that. Okay, we're going to get there. We're going to get there. Boy, this is hard to do without having just done it, just to do this from scratch on the fly. Okay, so let's see, new branch. So what I want to do is the new branch is going to start at the previous branch's end. And now I need to fill in where it ends. So how can I do that? Well, one thing I can do is I can make a vector that is the direction of this particular branch, right? What if I have a vector that points from here to there, a vector being an arrow that points from here to there. And the way that I can make that vector is by taking this point and subtracting this point. So I want to create a direction vector and say p5.vector.subtract. I want to subtract the end from the beginning. So now I have a vector that points from the bottom to the top of that branch. And one of the nice things about vectors is they actually have a rotate function built into them. So what if I were to rotate that vector by some angle, like 45 degrees or pi divided by 4? And then what if I were to create a new endpoint, new end, and I would say the new endpoint is where? It is add the endpoint of the previous vector with the direction. So in other words, what I'm saying is, let me come back over here again, is I now have this vector. Oh, wrong side of this pen. I now have this vector, okay? And then what I want to do is take this vector and rotate it by 45 degrees. And then I want to add this vector here. So this is the new endpoint. So this is the beginning, and this is the endpoint, and that's my branch. So now I can say the new branch goes from this dot end to the new end. That's to the right. Okay, so let's see how this works. So let me now go back to the main program, and I'm going to say new branch equals root.branch. Oh, what am I need to do something. So once I have that new branch, I need to return it. So I need to return it so that I can get it. And then what I can do is say tree index 1 equals new branch. So the 0 index of the array is the root, and then the next spot in the array is this new branch that came out of the root. Perfect. Look, now I have both of those. Now, I could probably cleverly create both of them in this function and then return both of them as an array and then add both of them. But I'm actually just going to call this function branch A. And then I'm going to do something kind of lazy and just make a function branch B and rotate the other direction. And, I'm just going to call this V or B. This is to the right, and this is to the left. So I'm just going to have two, again, a good programming exercise for you is like, how can you combine this into one function? Maybe you just pass in the angle. But just to be lazy and explicit for a second, I'm just going to have these duplicate functions. The only thing that's different is one is rotating to the right, one is rotating to the left. And I can go back to the main program, and I can say branch A. And I'm actually just going to combine this, say tree index 1 is branch A, and tree index 2 is root branch B. So now we can see this particular branch has two branches attached to it. Okay, things are going well now. Now, one thing that I want to do is, remember, I want to shrink the branches each time they're attached. So let's go back into this function here. This direction vector should also be multiplied by 0.67 in order to shrink it a little bit. And now you can see that it is now shrunk. So what I have now is I create a single branch object and it spawns two other branches. I need a mechanism for then having those two other branches spawn two more branches and two more branches. And maybe what I'll do is every time I click the mouse, I add two more branches. So let's figure out how we would do that. So let me go to Sketch, and I'm going to take this out. And I'm just going to say function mouse pressed global and put this here. So in mouse press, I'm going to add those two branches. So now two branches, click the mouse. Ooh, root is not defined. So I'm going to say tree, the thing that's global is the array. Tree index 0, tree index 0. So I'm going to add those two branches. And now I'm going to click the mouse. Two branches. There we go. Okay, so I'm getting somewhere. Now I have this ability to take an existing element of the array and add to it. So what I really want to do is not do it manually like this, but what I want to say is, hey, anything that's in the array, there are some number of branches in the array. What I want to do for everything that's in the array, I want to tree.add. So one way to add something to array is with the push function. I want to add tree index I dot branch A and tree index I branch B. So this is now an automatic way of saying whatever is in the array currently, go through everything in the array and add to the array with branches from the things that are in the array. Now, there are some problems here. Problem number one is, if I'm trying to loop through an array, like I'm looping, here's the beginning of the array, here's the end of the array, and I'm looping through it and I'm adding things to it. So as I'm going through the array is growing. I'm never going to get to the end. So one way to solve this would be to say, to actually start from the end of the array and go down to 0. This way, I can add things to the, like I'm going backwards through the array and new things can get added to the end that will then get ignored. So this should actually work, and I'm going to run this, and you can see I can click, and then I can click, and then I can click, and then I can click. So that's actually happening now. Each time I click, everything that's in the array gets 2 extra branches. But one thing that you might not be noticing here is that this particular root has been there every single cycle. So every time I go through that array, it gets 2 new branches. So there are multiple new branches being added over and over again in the same spot, which is very unnecessary. So one thing that I think could be useful to do is in the branch object, I could add a variable like, I'm going to call it grown or finished. I'll just call it finished. And it's going to, finished is going to be false. And in the branched function, you know, let's say I'm just going to say this.finished equals true. So whenever, and you know what, maybe I'm going to actually, since I have this branch A and branch B, I'm just going to do it out here. So I'm going to say tree index I dot finished equals true. So what I'm going to do is every time a tree branches, I'm going to say finished is true, and then I want to make sure if tree index I dot finished, only if the tree is not finished, should I actually add those branches. So now, you can see every time I click the mouse, I'm adding branches. Now, this might not seem very exciting to you, because ultimately, all I have here is exactly what I had before. But the difference is, I actually have an array of objects, and all of those objects store their location dynamically where they are. So there's no reason why I couldn't do weird things like in the branch function, in branch, I could say, I'm going to write a function called jitter, and I'm going to say this.n.x plus equal random -1, 1, this.n.y plus equal random -1, 1, 1. So one thing I'm going to do is I'm going to add this jitter function in draw, and I'm going to say tree show and tree index I dot jitter. So now if I run this, you can see, look at this, it's animating. And as I click, those are all animating and shaking and doing weird random things. So I'm not suggesting this is like a great result, because I don't know what I have here. I just have this random shaking weird tree. But you could imagine, what if you did something a bit more thoughtful? You were changing colors based on some logic, or maybe you were swaying with Perlin noise, or you applied some spring forces or a physics-based system to the tree. Boy, I really wanted somebody remind me someday to do a video where we take this tree and actually attach spring forces to all of it, so you can sort of like pull on it and it just goes, you know, it's all springy back into place or something. That's always a nice demonstration. So this opens up a lot of possibilities. It also opens up one last possibility that I want to show you in this particular video. So I'm going to turn off the jittering, and what I'm going to do is I am going to say, I'm going to keep track of a counter, and I'm going to just, every time I'm going to say count plus plus. And what I want to do is say if count equals 5. So if I've generated 5 generations of the tree, what I want to do is say for var I equals 0, I is less than tree.length, I plus plus. What I want to do is I'm going to make leaf objects. So I want to create an array called leaves. And then what I'm going to do is say, for all of those last branches, if and when I get to 5, any branch that hasn't branches at the end, what I want to do is make a leaf Where do I want to make that leaf? I want to make the leaf at that branch's endpoint. And you know what? I don't even need to say create vector because it is a vector. Tree index I dot end dot copy. So I want to go and grab that end point of that branch and make a copy of it. And then I'm going to say leaves dot push that leaf. So now in draw, I can also loop through all of the leaves. And I can say, now I should make the leaves an object, the leaves. I'm going to make some purplish leaves. And I'm going to just make them circles. You can be more creative. Dot y. So we should get now, let's run this. 0, wait, 1, 2, 3, 4, 5. So you see, so let's do a couple things. One is let's make that angle. Where did I decide what the angle is? The angle is right here. It's kind of like hard-coded in. So this, by the way, would be nice to make a variable. Maybe it could be slightly random. That could be the thing that's changing. But, oh, and I did something interesting. So for some reason, I'm going a different angle to each side, which is kind of nice. And let's go in Sketch. Let's actually go up to 6 levels. And let's say no stroke for the leaves and give it some alpha also. So you can see I now have little leaves at the end of the tree. And what's exciting about this is they aren't just circles on the screen. Those are all vector objects. And what I could actually do, if you go look at any of my other Nature of Code tutorials, I could treat those as particles that would fall with the wind or something like that. And just to sort of show very, very briefly, what I could do right now is I could move all the leaves by some random amount in the y direction. So once I get up to 6, you can see they're falling. Now again, I have made a really trivial, whoops. This is a trivial result. You know, I don't like necessarily that doesn't look like a very nice, glowing, beautiful physics movement, but you, in thinking about color and thinking about motion, all sorts of possibilities, you could have the branches be swaying, you could have a gust of wind, some of the leaves fall, some don't. What if you have a program where you shake the tree and the leaves fall off and they don't all fall off at the same time? All of the possibilities are now open to you because the fractal wasn't drawn through a single recursive function, but rather was drawn as a set of objects with position vectors. So all of those things could be manipulated after the fact. Thanks for watching this video. If you make something with this, please let me know, and I'll see you in the next one.